All right, I'm going to record this just in case. Okay, so 14. Now, do you have a specific question you want to ask?
Uh, yeah. Um, I don't understand why you subtract 40 from 25.
Uh, okay, well, because the question says, hang on a sec while I get my pen here. So the question says 4 seconds. Oops, why is it doing that? Hang on. Okay, let's switch to a different color. Okay, so the question says we want to know what the velocity is going to be like uh, 4 seconds after it's been thrown. Okay, right? So if it initially, let's see, let me open up a whiteboard here. All right, so at time t equals 0, we threw the ball upward and it had a velocity of 25 meters per second. So let's make a graph of time versus velocity. So when time was 0, the velocity was 25 meters per second upward. And the acceleration due to gravity is 9.8 meters per second downward. And since this is part 1 of the test where I told students they weren't allowed to use calculators, remember I wrote this a couple years ago. Okay, so what I told them was if you're not allowed to use a calculator, instead of calling it 9.8, let's just call it 10. Okay, it's close enough for our purposes here. So that means every second that goes by, our velocity is going to be 10 meters per second less than it was. So 1 second later, it's going to be 25 minus 10, which is 15. Another second after that is going to be 5. Another second after that is going to be negative 5, or in other words, 5 downwards. And another second after that is going to be negative 15, or in other words, 15 down. Okay, so where the 40 came from is velocity final equals velocity initial plus AT. T was 4, and A is really 9.8. But since we're not using a calculator, I told students it's okay to get away with just calling it 10, but don't forget it's negative 10. So that's where the 40 came from right there. Does that answer your question?
Yeah, thank you.
Okay, all right. Okay. Any other questions that you guys have? So Derek, I think you said you had another question besides just that one?
Yeah, 14 and 15. So could you go over 15, please?
Okay, so 15 is a really important one. It's one that I went over in class, but it's worth going over it again. Okay, so what I gave you initially was just the position versus time graph. None of this was there. All you had was the position versus time graph. Okay, and you were supposed to create a velocity versus time graph based on what you saw from the position versus time graph. So do you agree that the slope of this graph equals your speed? Actually, I should say velocity, because if you worry about positive and negative, there's really more to say. The slope equals the velocity.
Yeah.
Okay, so all we have to do is just look and see what the velocity is. So during this section right here, the velocity is clearly 0. Okay, and during this section right here, the velocity, you'll notice it's a straight line. So the slope here is the same as the slope here, is the same as the slope here. So it's some negative number. Since we don't have tick marks on the graph here, we can't calculate exactly what it is, what number it is, but it's clearly some negative number. All right. And now the tricky part is right here. So during this section right here, that looks to me like a straight line. So you'll see that, and it's some positive number. All right, so I can't exactly say what number it is, but it's some positive number. Okay, and so this is the interesting part right there. Okay, if we look at this point right here, the slope of right there starts off at 0, and now the slope becomes a little bit more positive, and here the slope becomes positive. So you can see what's happening is the slope is going up, and then right about here is where it levels off, and then right here is just definitely 0. Okay, so that's where I got it from. Does that answer your question?
Yeah.
All right. And you guys understand about this this part right here, where because we've got a sharp kink in the graph, what that means is that our slope went from some non-zero number down to 0 instantly, which is not possible in real life. So that means that this graph here has a serious problem in it. So we just need to recognize that what we really should have done is this graph here should have been rounded off there and should have been rounded off there. So that would allow this, instead of being an instantaneous shift, it's more of a gradual shift. All right. Okay, so those are important questions. I'm glad that you asked them. Any other questions that you guys have?
Oh, I had a question on, I don't know which one it was, but oh, it was 12, and you said on the practice test that it was 40, but like the calculator itself says 39.2.
Right.
And I don't know, I don't understand how it would go from 39.2 to 40 instead of 39.
Well, if you were allowed 2 sig figs, then I agree with you. 39 would be the right number. But are we allowed 2 sig figs? So if we're going to call the acceleration as being 10 rather than 9.8, okay? So notice here that instead of calling the acceleration 9.8, we're calling it 10. So there's only 1 sig fig in there. And this 4 here, you could argue, whether that's exactly 4 or approximately 4. But if we're going to use 10 as the acceleration due to gravity, that means we're only allowed 1 sig fig in our numbers. We're not allowed 2 sig figs. Now, if we had used 9.8 as our number, and if it was exactly 4 seconds rather than just approximately 4 seconds, then I'll agree with you. Then we could have rounded that off to 39. Oops, that's supposed to be a 9. It's not a 9. Okay. Okay. So
Okay.
if we were allowed 2 sig figs, then I would agree with you. But what I told the students when I made this up a couple years ago was I told them on part 1 of the test here, where you're not allowed to use a calculator, just instead of calling it 9.8, just call it 10. And then that way you've only got 1 sig fig.
Okay. On the test, are you going to say if we should use 10 or 9.8?
Well, on the test that you guys take, you are going to be using a calculator on all parts of the test. So that means that you have no excuse not to use 9.8. Now,
Okay.
the students a couple of years ago on part 1 of the test, I told them they weren't allowed to use a calculator. So in that case, it made sense for them to use 10. But you guys don't have that excuse. You're going to have a calculator on the entire test. Therefore, I want you to use 9.8 on the entire test.
All right. Thank you.
Okay. Those are really important questions. Thank you. Keep them coming. How about the rest of you guys?
Can we ask questions not about the practice test?
Absolutely.
So I was redoing the quizzes so that I could raise up my scores.
Mhm.
And on quiz 2B, the very last question, I tried for about an hour to get this one right, and I could not figure it out for the life of me.
Okay.
And I was just wondering if you could work through
You got it.
question 7.
Absolutely. Now, I don't have it handy. Do you have it handy? Can you read it to me?
Yeah. So
Okay.
it says, so I think it's based off of the question used for the whole quiz. So do you want me to read the top part too?
Yeah, please.
So, okay. A car drives north at 50 miles per hour for 3 hours.
Okay, hang on a sec. Let me capture
Sorry.
that. I can't write that fast. Okay, so 50 miles per hour for 3 hours.
Mm-hmm.
Okay, and is it 3.0 hours?
3.00.
Oh, so we got 3 sig figs in all these.
Yeah, and then the
Okay.
other one is 50.0.
Okay. All right. So it drove north and then it turns around and drives back south again.
Mhm.
Okay, and how fast is it going then?
And then immediately turns around and drives south at 70.0 miles per hour
For 1 hour,
for
right?
1 hour.
1.00 hours. Okay. All right, got that. Okay,
Okay.
so let's just keep track of it. So we got 50 times 3. So that means we went 150 miles to the north and we went 70 miles to the south. So when we're done, we are now 80 miles to the north of our starting point. Okay, and now the next part is asking about the bicycle, right?
Yeah. And yeah. Do you want me to read that question really
Yes,
fast?
please. Yeah.
Okay. One person drives a car as described above and then stops. A
Mhm.
second person starts from the same place that the car driver started, at the same time that the car driver started, and rides a bicycle to the north at a speed of 18 miles per hour.
And 18.0, right?
Yeah, sorry.
Okay, that's okay. I just want to make sure we have enough sig figs here.
Okay.
Okay.
And then it says, how many minutes will the first person have to wait after ending their journey before the second person arrives at that same place?
Okay. All right. So the first thing we need to do is we need to figure out how much time the car guy is driving. So he goes for 3 hours to the north and then 1 hour coming back. So the car then goes for a total of 4 hours. And that's 4.00. There's 3 sig figs in all these numbers. So then the question is, how much time does it take the bicyclist to get to this location? Now, some people mistakenly thought that the bicyclist was doing the same route that the car did. They thought that the bike went all the way here and then all the way back, but that's not what the bike does. The bike just goes until he finally meets up with the car again. So the bike goes a total distance of 80 miles and goes at a speed of 18 miles per hour. So if we take everybody's favorite equation, dirt, and if we solve that for time, so let's divide both sides by r. So time then equals d divided by r. And so the distance is 80.0. The rate, which is the velocity, is 18.0. Okay. So that tells me the time that it took. So 80 divided by 18. So I get 4.444 hours. Okay. All right. So the car, it only took them 4 hours to get there. So the bike took them 4.4 hours to get there. So then that means that the car had to wait for 0.4444 hours. Do you agree?
Yeah.
Okay. All right. So then all we have to do then is convert that into minutes. So can I just say that we multiply by 60? I mean, everybody's good enough with converting units, right? So if I just take that last number and I times it by 60, so I get, let me write up in the corner here. So we get 26.666 repeating. That's how many minutes the car driver had to wait. Now, if I put that into Canvas, Canvas is going to mark it wrong because I specifically told you, you got to give your answer in the right number of sig figs. So how am I going to round that off? So if I'm allowed 3 sig figs, how should I round that number off? Do I round it down to 26.6 or do I round it up to 26.7?
26.7.
Yep, 26.7 is the right answer. And so if you put that into Canvas, it should have marked it right because it did for other people. So
Yeah, I was having issues where I was rounding up too soon to the 3 sig figs. So instead of getting I got like, I don't know, I got 10 different answers because I did this problem so many times trying to figure out what I was doing wrong.
Yeah, well, other people told me they had the same problem. They said that they rounded off too soon. Okay, so everybody. Let me stop here sharing here so I can look you in the eye here. Do not round off your numbers until you get to the very end. You're going to run into all sorts of problems if you round off too soon, right? Now, you don't need to have like 9 sig figs all the way through. You only need like 1 or 2 extra sig figs. But yeah, do not round off until you get to the very end. Okay. Did that answer your question?
Yeah.
Okay, good. Anybody else? No, go ahead.
Sorry, I have one more question. I
Uh-huh.
was wondering, I'm just still a little bit confused about sig figs when it comes to addition and subtraction, because I keep making mistakes on that and I'm not sure what I'm doing wrong. Could you
Okay.
go over that really quick?
Yeah, I can. One of the problems on the test was specifically designed to test that. All right. So look at problems 2 and 3. That's exactly what I had in mind when I created these problems here. So a lot of people, they know the rule for when you're multiplying or dividing. Okay. They know that when you're multiplying or dividing, whichever number has the least number of sig figs, that's how many sig figs you're allowed in your final answer. So so you see here, I've got 60.0, and then we're going to take some really big number with a whole lot of sig figs. We're going to divide it by 60.0. And so we're only allowed to have 3 sig figs. Most people understand that just fine. The problem is they then try to apply that same rule when they're adding or subtracting. So if we look up here at problem number 2, okay, problem number 2 is an addition problem. And so what a lot of people do is they take these numbers and they put them in their calculator. So the calculator gives them 14.3387. That's the number that appears in their calculator. And then the mistake that they make is they say, well, this number has 5 sig figs, this number has 3 sig figs, therefore I better round my number off to where it only has 3 sig figs. And so they call it 14.3. And that is wrong, because when you're adding and subtracting, you have to follow this other rule here. What you need to do is you need to take the numbers and line them up so that the decimal points are directly above each other. Okay. And then you write the numbers out, and you'll notice that 9.12 is really 9.12 question mark, question mark, question mark, right? So what I do then is I put a dotted line at wherever the question marks begin. So where that dotted line is, that is where I need to stop with my significant figures, okay? So you'll see that my final answer here, 14.34, has 4 sig figs in it, not 3. But that's okay, because that's the way the rule works here. Now, some of you might say, but wait a minute, Mr. Hendricks, 1 plus 2 is 3. Where did I get that 4 from? And you guys know what that is? Okay, so if I look at this column here, this is the first column where I've got question marks. And so I may not know what digit goes there, but I know it's at least 8, right? So it's probably more than 8, but it's at least 8. So this question mark here is a number that's at least 8. Therefore, I better round up. I better carry the 1. So instead of calling it 14.33, I know I need to round it up to 14.34. Does that answer your question?
What if you have multiplication and addition in the same problem?
Okay. Then what you're going to have to do is when you do the multiplication part, follow the rule down here. And when you do the addition part, follow the rule up here.
So would you round, instead of, you're rounding 8 up to 10 instead of 9?
Well, I'm doing the rounding right here. So here, let me write this number down for a sec, because I'm going to open up a white screen so I can have more room. 5.2187 and 9.12. Okay, so now let me open up a whiteboard here. And let's get rid of that. Okay, so what I've got is I've got 5.2187 and I've got 9.12 question mark, okay. All right, so what is 7 plus question mark? Well, question mark. What is 8 plus question mark? Well, it's question mark, but I know it's at least 8, okay? So when I say what is 1 plus 2, well, I'm tempted to write 3. Well, in fact, let's go ahead, let's write 3 for right now. Okay, and then 2 plus 1 is 3. There's a decimal point. 5 plus 9 is 14. Okay, so what I've got is I've got a number that's 14.33 question mark. So the question, so now I need to decide how am I going to round this? I could round it down to 14.33, or my other option is to round it up to 14.34. And the reason I know that I have to round it up and instead of down is because this number right here, I know is at least 8, okay? So even if this question mark right here, even if it was a 0, this number right here is still going to be greater than 5. So it's going to have to round up, not down.
That makes sense. Thanks.
Okay, you're welcome.
With significant figures, so I didn't quite understand your answer with multiplying and then addition. So if you have a problem and then you start off with multiplying, and then with the answer that you've multiplied, you then have to add to another number. At the end of the problem, would you use the multiplication rule for sig figs or the addition rule for sig figs?
Let's do an example. Let's take 3.14159, which is a number you guys should all recognize, times 2.7 plus 12.91. Is that a reasonable example to work on? Okay, so I'm gonna take those numbers. So first I'm gonna do the multiplication first. Let's see what my calculator tells me. 3.14159 times 2.7. All right, so my calculator tells me 8.482293. Okay. Now, I really cannot trust these numbers right here because this 2.7 is actually 2.7 question mark. So I really can't trust those numbers right there. So I'm going to have to round to 2 sig figs. And I know this number here is 8, so I'm going to round up. So that's going to give me 8.5. So this right here works out to be 8.5. And so now I take my 8.5 and I add it to that. So there's 8.5. Notice it's 8.5 question mark because I don't really know what comes after that 5. All right. So then what I do is I draw my dotted line where the question mark appears. So what I've got, what is 1 plus question mark? Well, it's question mark. What is 9 plus 5? Well, 4 carry the 1. 8 plus 3 is 13. It was not 13. Sorry. Okay. Okay, so 8 plus 3 is 11. Carry the 1. So my answer is 21.4 and then question mark. Okay. So that would be my answer right there. So notice I've got 3 sig figs in it. This number here only had 2 sig figs, but because I followed through the rules, I got an answer that has 3 sig figs in it.
Thank
That
you.
help? Okay.
Yeah.
All right.
So I was just also wondering, like, if you have, like, let's say, like, 24.345, I don't know, like, plus, like, 9 point something, like, how do you figure out that? Because, like, what confuses me is, like, having that first number be bigger than the whole number of the, if that makes sense. I don't know how.
All right, well, let's use your example. So 24.345, okay, plus 9, right? That's what you gave me. When you said 9 point something, I interpret that as being 9 with only 1 sig fig in it. Okay, So here is the procedure. Take the two numbers and put them one above the other, but make sure that the decimal points line up. Okay. So what I've got is 24.345 plus 9 point question mark, question mark, question mark. And so at which column do the question marks first appear? Well, the question marks first appear at that column right there. Okay, so what is 5 plus question mark? Well, question mark. What is 4 plus question mark? Question mark. What is 3 plus question mark? Question mark. Okay, so now finally we get to the place where we don't have question marks. What's 4 plus 9? Well, it's 13, carry the 1, so 3. So 33 point question mark is my answer. And now I need to decide, do I round that down to 33 or do I round that up to 34? So I look at this number that's a question mark and I see, well, I know it's at least 3. And it might be, because I don't know what this question mark is. So I can easily understand some people might make a good argument for why I should round it up to 34. Whereas other people would say, no, let's just round it down to 33. So in this case, I don't have a good rule for you to follow. If someone was a statistician, they'd say, well, what are the odds of this number being less than 5? What are the odds of it being greater than 5? I don't want to get into that level of detail. If we get into that level of detail, we're just going to drive ourselves crazy. So I would be okay with you just rounding it down to 33. I would be fine. If others of you said, well, I really would prefer to round it up to 34, I would give you credit because you would have a good argument for doing so. So in this case, I'd have to give you credit for either one of them. Does that answer your question?
Yep.
Okay.
Okay. I have a question. Would it be cool if we did some of those like big scary problems with the equations and stuff?
Absolutely.
Okay.
That was.
Would it be cool if like you made up numbers and then gave us like, I don't know, 5 minutes to try to solve it out ourselves or something?
Okay. I can do that. So tell you what I'll do. I'll make up a problem right now. I'll give you as much time as you want to work on it. And while you're doing that, if someone else would rather ask another question, we can do that. So let me pull up a whiteboard here and get rid of all this. Okay, so here is a problem very much like you will see. I guarantee you will see a problem like this on the test. Okay, so here's the ground level. Here's some building. Here's a person standing on the building. And they're holding a rock in their hand. Okay, they throw the rock upward at some velocity. So Derek, what would you like that velocity to be? Give me a number, any number.
25.
Okay, so and let's make it point something.
0.7.
Okay, 25.7 meters per second. Okay, all right. And so the rock is going to go straight up and then it's going to turn around and it's come back down again. And the person is not going to catch it. They're just going to let it fall and it's going to hit the ground. Okay, so your job is to find out how much time does it take to hit the ground. Now there's one other piece of information that you're going to need to know. You're going to need to know what is the initial height above the ground. So Derek, what would you like that number to be? Give me a number, any number.
12.6 feet.
Oh,
or no, I mean meters.
So meters.
Sorry.
Okay,
sorry.
good. All right. So the thing starts off at 12.6 meters above the ground, and it starts off with a velocity of 25.7. I want you to tell me how much time is it going to take before it hits the ground. Okay, so you start working on that one. I would recommend everybody work on this one. This is the kind of problem that is going to give most people the most difficulty. So I'll let you work on that for a while. And while you're working on that, do you all want to work on that, or does somebody else want to ask another question while he's working on that? So I see that Adam typed something into the chat box a while ago, and I was so busy I didn't see it until now. But it looks like Caleb already answered the question for him. Yeah, so this is whatever questions you might have. It doesn't have to be the practice test. I mean, if nobody else asks questions, then the practice test is what I intended to go over. But as you saw, we had plenty of other questions, and so ask anything. Ask about the meaning of life if you want. I don't care. Are you guys quiet because you're working on this problem that Derek wanted?
Yeah.
Yeah.
Okay. All right. That's a good thing to be working on. Okay, so let me turn my whiteboard back on again. Okay, so there's all the information. So I'll sit here quietly. Let's see what you get.
V0 is also V initial, right? The same
Yes.
thing.
Yeah, V initial and V0 are just two different things that mean the exact same thing. And my V there looks kind of like an R. Let's make it look more like a V. Yeah, those two guys mean the same thing. How about if, while we're working on this, how about if one of you is brave and willing to step us through what you're doing, what you're thinking? Any of you want to be the brave person to volunteer to do that? Nobody wants to volunteer. How about Fatima? Would you be willing to walk us through your thought process as you solve this problem?
I know that we gotta use like the mother of all equations,
Now, how did you know that that's the right equation to use?
because we don't have a V final and we're trying to find a time.
Okay, you guys agree? If you look at all those equations, which by the way, I hope that you've printed out that sheet that I gave you and you got it sitting right next to you. Okay, so we don't have a V final. So there's really only one choice that we can possibly go with, and that's going to be the mother of all motion equations. So X final equals X initial plus V initial t plus 1/2 AT squared. And I'm going to take these other numbers and I'm going to write them over on the left side here so that I have some room to do what we need to do. Okay. All right, so Fatima, I think you're off to a really good start. What do you recommend we do next?
Plug in numbers.
Okay, now normally I don't like plugging in the numbers because we have to do a lot of algebra, right? And it's easier to do the algebra using the letters. But notice how we've got a t here and we've got a t squared here. So if we try to solve this problem using what I like to call the 9th grade method, where we subtract x initial and then we try to divide by v initial, we're going to get ourselves in trouble because that isn't going to work on this top problem. This is a quadratic equation. And so the only way we're going to be able to solve this one is using the quadratic formula. So here is where I definitely agree with by the way, Fatima, I worry that I'm not pronouncing your name correctly. I'm worried that I'm not putting the emphasis on the correct syllable. Can you say your name the way that you like it pronounced?
Fatima.
Fatima. Oh, that's a
Yeah.
good thing I asked, because otherwise I would have said it wrong. Okay, so I'll try to remember that. Okay, so Fatima is saying that we should just put in the numbers. All right, and I completely agree with her. Now we've got a little bit of a problem because we haven't yet decided where our origin is. So if I were to make a list of all the Dr. Seuss variables, x naught, xf, v naught, vf, a, and t, okay? So we've decided that v naught was 25.7. Notice we put it in as a positive number. So Fatima, what does that mean about our positive direction? Did we choose positive direction up or did we choose positive direction down?
Positive direction up,
Yeah,
right?
because if we threw the ball upward and we called that a positive 25.7, that means we must have defined the plus direction be up without even thinking about it. Okay, so that's one of the jobs that we have to do. There's one more job that we have to do before we can start filling in the rest of these numbers. We need to decide where we want the origin to be. So Fatima, when you did it, where did you put your origin?
I really don't know, but I put X initial as 12.6.
Okay, so if
So
she
I think
put,
that means,
go ahead, finish your
I think
sentence.
that means, yeah, I think that means the origin is at the top, right?
Oh,
Oh, at the
really?
bottom. It's at the bottom.
Yeah, it means it's at the bottom. So Fatima put her origin down here at the bottom because X naught, what does that stand for? It stands for how far away from the origin is the object when we started the clock. So if she said that the object was 12.6, oops, sorry, keep doing that. So if she said that the object was 12.6 meters away from the origin, she must have put the origin down here. That's the only way that could possibly be. All right. Now tell you what, just for fun here, let's do this problem two different ways. And so I'm going to say that I don't like the way Fatima did it. I want to put my origin up there at the top just because I like to be different. So for me, X naught then is going to be 0, but for Fatima, it's going to be 12.6. And tell you what else I'm going to do, because I'm really feeling contrary today. I am going to define my plus direction to be down. So that means my initial velocity is not going to be a positive 25.7. My initial velocity is going to be a negative 25.7. Okay. All right. So Fatima, what is your X final going to be?
0.
You guys agree? Because when the ball hits the ground, that's when we stop the clock. So if she put her origin down at the bottom, that means her X final is going to be 0. And I agree with that. But what's it going to be for me? Because my origin is up here at the top. So when the ball gets down here to the bottom, what is X final going to be for me?
12.6.
12.6. Is it going to be positive 12.6 or is it going to be negative 12.6?
Positive.
Yes, it's going to be positive because I defined the plus direction to be down, right? So if it's down here, that means it's on the positive side of my origin. So yes, okay. All right. And so let's continue on. So Fatima, what is V final going to be for you? By the way,
We find out, would that be just 0 too?
I'm glad you said that, Fatima. I'll pay you later. That is a very, very common mistake. Okay, so, and I'm really, really glad you did that. I mean, honestly, because so many people make that mistake. So somebody else, please speak up and tell me, why is X final not 0?
We don't know what it is, so
Yeah,
we
but
just leave it as a question mark.
I mean, what you said is true. The answer I was looking for is the reason that X final, or I'm V final is what I meant to say. The reason that V final is not 0 is because these equations of motion only apply while the rock is in the air. As soon as the rock hits the ground, these equations no longer apply. And you may remember the example that I used during class. I said, in fact, let me stop sharing for a second. So imagine that I throw my pen up in the air. Okay, so it's up in the air and I can use the equations to calculate where it is, but as it's falling, a bird comes and grabs it and the bird flies off with it. Would you expect that the equations would still apply? I mean, obviously not, right? Hitting the ground is the same thing. The equations of motion only apply while the object is in the air. When that object hits the ground, then that's the same as if a bird had grabbed it and flown off with it. The equations no longer apply after it hits the ground. So that's why V final is not 0. V final is something that we don't know. And if we're lucky, maybe we don't need to know it. The question doesn't ask for it, right? So let's just put it in as a question mark. And let's just say that, you know, maybe if we're lucky, we don't need to know it. All right, so if it,
final will never be 0.
well, if you mean after it hits the ground, yeah, it will never be 0. Now, if I wanted to know what was happening up here at the very top, you see where I'm circling right there? The velocity up there would be 0, but down here, no, never going to be. It's not going to be 0 down there. All right, so Fatima, back to you now. What number are you going to use for acceleration?
Negative 9.8.
You guys agree? Negative, oops, let me,
Yeah.
okay, so negative 9.8. But me, I define things differently. So what is acceleration going to be for me in blue?
9.8 positive.
Positive 9.8. Okay, good. All right, and then what is time? Well, we don't know. And in fact, that's what we're looking for. So notice how I like to put a box around it. That reminds me that's what we're looking for. Okay, so let's do this 2 ways. Let's do it first using Fatima's numbers, and then we'll come back a second time and do it using my numbers. And it's gonna look very, very different, but I promise you in the end, we will get the same answer. And if we don't, then that means physics is broke and then we can all go home, which I realize isn't very much, seeing how we're already home anyway. Okay, so can I erase the drawing over here now? I'm going to do that. I'm going to erase the drawing because I'm going to need all the room I can possibly get.
Hey, I have a question really fast. Like, how do you know that it's quadratic when you look at an equation? Like,
Well,
you know it will have to be.
I see a t squared. Let me finish. I see a t squared right here, and I see a t. Why is it not doing it? And I see a t right there. That's what tells me it's a quadratic. Did that answer your question?
Yep.
Okay.
And also, can you go like slowly through the algebra this time? Because sometimes it gets confusing.
Yeah, that's one thing that I recognize during class. I am going a lot faster than I would really like to go, but that's the only way we can get all the material in. So yeah, I'll do it really nice and slowly here. But actually, you know, I don't really have any algebra to do here. I'm just going to use the quadratic formula. All right, so let me change to a red pen because I'm going to do Fatima's numbers first. So for Fatima, x final, oops, why did it do that? Okay, hang on a second here. I don't know if it did it for you guys or not, but for me, it just, okay, it just switched over. Okay, so I'm going to switch to a red pen here. So I'm going to do Fatima's numbers first. So x final is 0 equals x initial, which is 12.6, plus v initial, which for Fatima is 25.7. Okay, plus 1/2 times the acceleration, which for Fatima is negative 9.8. Oh, I left out a t here. Sorry, I left out a t. Okay, so 25.7 times t plus 1/2 times negative 9.8 times t squared. All right, so once we get it to this point right here, we say, okay, it's time to sing the song, you know, x equals negative b, and all that fun stuff. I would hope that you guys have the quadratic formula programmed into your calculator, okay? You really, really, really need to get the quadratic formula programmed into your calculator. Now, just in case you don't have it programmed into your calculator, let me show you something that you guys are going to like. Let me share my screen here. Okay. Okay, So if you guys go to the dashboard, and so go to Physics H, and you come down here to class resources. We haven't looked very much in class resources. Let's look in there now. Okay, so if I look in class resources, you'll see that I've got this, this page right here. I think I showed this to some of you. I don't know if I showed it to all of you. This video right here tells how to program your TI-83 or 84 to do the quadratic formula for you. This video right here shows how to program your TI-Nspire to do the quadratic formula for you. But if we go back to this page, you'll see that I've also got another thing right here that says for an online calculator that'll do quadratic equations for you, click here. So let's do that. Let's click there. Let's see what we get. Okay, so notice we've got A equals B equals C equals, right? So let's go back here to the screen or to the whiteboard again. Okay, so we need to decide what is A. So when they say A, they mean, remember when you first learned about quadratic problems in your math class, you had something where you said A0 equals AX squared plus BX, oops. Yeah, that's right, sorry, plus C, right? This is the standard form that I'm sure your math teacher taught you. All right, so we need to figure out what is A, what is B, what is C. So how about this 12.6? Is that A?
No.
Very good, because you notice it doesn't have a variable attached to it. So 12.6 is not going to be A. 12.6 is going to be C, right? What is B? Well, B is the coefficient of the X term. Actually, you know, they wrote it as AX squared. For us, it's going to be A times T squared plus B times T plus C. All right, so for us, that number right there, that's our B value. So that's 25.7. And this number right here is our C value, 1/2 times negative 9.8. So that's negative 4.9. So there's our A, B, and C. So let me write that down because I'm going to have to go back to the other screen. I want to remember. So A is negative 4.9, B is a positive 25.7, and C is a positive 12.6. Okay, so let's go back to this page right here. And so you just type in the numbers there. So A then is negative 4.9. Tab down. Oh, no. Yeah, okay, right. B is 25.7. And C is 12.6. Hit calculate, and you'll notice we get two answers. One of them is negative. So what do we do with that negative number there? Because remember, it's not really X, it's really T, right? So is it possible for time to be negative?
No.
No. So this is what we call an extraneous solution. That's a word that I trust your math teacher has already talked to you about. That's an extraneous solution, so we can ignore that. So this one right here is the answer we want. And so 5.69632, that's our answer. Okay. Or maybe I should say that is Fatima's answer. But will it be my answer? Because remember, I did it differently. Okay, so let's go back here. Let's go back to the whiteboard. Okay, and so let's see what I get. So you'll notice I have different numbers. So when I put my numbers into this equation, let me do it up on top here. So for me, X final is 12.6, right? So I have to put in a 12.6. And for me, X initial is 0, so I put in a 0. For me, V initial is negative 25.7, so negative 25.7 times t, and then plus 1/2 times a, which for me, it's a positive 9.8. And then t squared. All right. So I want now to use the quadratic formula, but what is it I have to do before I can use the quadratic formula? I've got to get it in the form, see, I have to get it in the form of 0 equals that thing. So that 12.6 there is going to cause me problems. I can't use the quadratic formula until I get rid of that guy. Okay, so let's subtract a 12.6 from each side. Okay, so that goes away. So I'm left with 0 equals negative 12.6 minus 25.7. Why is it not working right? And then plus 4.9 times t squared. And I keep leaving out my t. Okay, so this number for me is a. So for me, a is negative. Well, I'm sorry. For me, is the a is this. Sorry. Okay, so for me, a is a positive 4.9. And for me, that's my b value. It's a negative 25.7. Okay. And the c value for me is a negative 12.6. So you see, I've got very different numbers than Fatima has. So I'm getting a little bit worried here. Maybe physics is going to be broke. We'll have to see. Okay. So let me write the numbers down here. Okay. All right. So now let me go back to our quadratic formula calculator. Okay. And let's clear all those guys out. And I'll just hit clear. That's a better way to do it. Okay. So for me, it's not negative 4.9. For me, it's a positive 4.9. And B is not a positive 25.7 for me. For me, it's a negative 25.7. Okay. And for me, C is not a positive 12.6. For me, it's a negative 12.6. Okay, so here comes the moment of truth. I'm going to hit calculate. If I get a different answer than Fatima got, that means physics is broke and we can all go home. And the answer is, hey, it's exactly the same. Isn't that nice? Okay, except you may remember that for when Fatima did it, she had her extraneous solution was the one on top. For me, my extraneous solution is the one on the bottom. Okay, but who cares? It's the same number. Look at that. It's exactly the same number. So what I do then is I wipe my brow and I say, phew, boy, I'm relieved, because I was pretty worried there for a minute that physics might be broke. Okay, so does that answer your question?
Yeah. So the way that you know if you're gonna have to do it quadratic is if you don't know time and time is squared.
Okay, I'm very glad you asked that question. It's not an easy yes or no to that question here. Let me do another problem that is similar. Let's say that we've got the same person on the same building. And so let's say that it's still 12.6 meters, just like it was before. But this time we're going to drop the rock instead of throwing the rock. Okay, so what does that mean about our V initial? Somebody speak up.
That it's 0.
Okay, it means that it's 0. Okay, but everything else is the same. All right, so I want to know how much time does it take to hit the ground. So I'm going to use the mother of all motion equation. So x final equals x initial plus v initial t plus 1/2 at squared. And let's do it Fatima's way. Let me switch to red here. So let's assume that our origin is down at the bottom. So that means x final is 0. That means x initial is 12.6. V initial is 0 this time. So this term right here goes away. And so we're left with acceleration. So Fatima decided she wanted it to be up. So for it, this is going to be a negative 9.8. So it's going to be negative 4.9 times t squared. So if I look at this, I say, well, I could solve that using the quadratic formula. I mean, there's no reason in the world I couldn't use the quadratic formula. I could put in A equals negative 4.9. I could say B equals 0. I could say C equals 12.6. I could go back to my other screen there. So, okay. So I could go back to here, and so I can put in negative 4.9. And now B is going to be 0 because we dropped the rock rather than threw the rock. And C is going to be 12.6. Okay. And when we calculate it, we get 2 answers, but those 2 answers work out to be the same, except one of them is negative, but it's the same number. Okay. So you can see I very definitely could have solved that problem using the quadratic formula, but I didn't have to. Let me go back. I'm sharing my screen again. Notice this time around, I have a t squared, but I don't have a t this time. So if I wanted to solve this one using what I like to call the 9th grade method for solving, I could do it. So let's solve this the way that a 9th grader would solve it. So a 9th grader would say, well, let's subtract 12.6 from each side. So that gives me negative 12.6 equals negative 4.9 times t squared. Okay, so then let's divide both sides by negative 4.9. Okay, so that goes away. And I'm left with t squared, so let's take the square root of that. So if we so we can just put that into our calculators, and guess what? We'll get the exact same number that we got by using that quadratic formula thing. Okay, so the question that you asked was, how do you know when you need to use the quadratic formula? Well, the answer is, if you have a t squared and you also have a t, then you have to use the quadratic formula. You have no choice. But if you have a t squared, but you don't have a t, then if you want, you could use the 9th grade method to solve it. You don't have to use the quadratic formula, but you could if you wanted. The quadratic formula will still work. Does that make sense?
Yes, thank you.
Okay, all right, good. And so those are great, very important questions. I'm really glad you guys asked those questions. And I suspect that those of you who are watching are equally glad. I wish that we had had time in class to go over it nice and slowly and carefully like this. We just didn't. Any other questions?
Hey, I have a question about, I forgot which homework this was. I think it was like the first one in chapter, so 3A probably. But it's like this may be a ridiculously simple question, but it's problem number 1.
Okay, can you read
in
me?
section 3.1.
Can you read me all the stuff I need to know?
Okay, so it's just about motion diagrams, just by the way. So,
Okay, right.
So it says, a dog runs into a room and sees a cat at the other end of the room. The dog instantly stops running, but slides along the wood floor until he stops.
Okay,
By slowing down with a constant acceleration.
Okay.
Sketch a motion diagram for the situation and use the velocity vectors to find the acceleration vector.
Okay. If that's an important question. I'm very, very glad you asked it. Okay, so can you draw the motion diagram for us? You should be able to draw on the screen right now. You have the ability to do it. So turn on annotation and draw me the diagram, the dot diagram. Or if you want, I can draw it for you. You want me to just draw it for you?
Yeah, I'm a little bit
Okay.
confused on how to draw. I mean, I
Okay.
did look at the answers, but I was confused on.
Okay, all right, I'll do it. I have a touchscreen computer that makes it way easier to draw. Okay, so when the dog is first running into the room, let's say he's running at constant velocity. So the dot, actually, let me make them a little bit further apart. Okay. And in fact, even let me make them be, I'm going to use the thick pen for it. Okay, so here's the dog 1 second later, here's the dog 1 second later, and now this is the point where the dog sees the cat. All right, so the dog is going to stop running, except the floor is really slippery, so the dog's going to slide. So this next dot needs to be a little bit closer than the other previous ones had been. And the next one after that needs to be a little closer still, and the next one's out a little closer still. And then finally right here, the dog finally comes to a stop. All right, so let's draw some displacement vectors here. So the first displacement vector is going to look like that. So that's my delta x vector. And then my next one is going to look like that. That's my delta x vector. And you'll notice that those guys are the same. Yeah, when I put this little mark right above there, that's just a symbol that just reminds me that it's a vector. That's all that means. Don't let that freak you out, okay? So if I wanted to draw the velocity vector, okay, velocity is defined as delta x divided by delta t. So if I say that this is t equals 0 and this is t equals 1 and this is t equals 2, then each one of the time intervals there is just 1 second. So delta t equals 1 second. So if I define it that way, then the length of my velocity vector is the same as my delta x vector. So if I wanted to draw my velocity vectors, let's say they're in red. So my velocity vector looks like that. And then the second time period, my velocity vector looks like that. And then the third time, my velocity vector now, notice how my velocity vector is shorter. So this is my v3 vector. That's supposed to be a 3. Let me try that again. Okay, so this is my v2 vector. This is my v1 vector. And so notice my v4 vector is even slower still. That's my v4 vector. Okay, so acceleration is defined as the change in velocity divided by the change in time. So if I look at let's look at this time period here in between time, in between the second and the third second. Delta V means, actually, hang on a sec, let me clear some space here. Delta V is defined as V final minus V initial, okay? So my V final vector, that's this guy right here. So that's a vector that looks like this. My V initial vector is this guy right here. So that's a vector that looks like this, okay? That's my delta V vector, okay? So if now, here I'm going to have to go into some depth. I purposely kind of skipped over this because if I had talked about this during class, it would have taken way too much time. But now that we have the time, what we need to do is we need to subtract two vectors. Well, before we can learn how to subtract vectors, we first need to learn how to add vectors. So let's see, how can I how can I do this? Let me go to a new share screen here. I don't want to erase the whiteboard that I've got. Not going to let me do this. I know what I'll do here. I'll open up a PowerPoint presentation. So hang on while this opens up here. My computer's running a little slow right now. What we're going to talk about will become very important later. So it's a good thing that we're doing it right now. I'm just waiting for my PowerPoint thing to open. My computer is just ridiculously slow right now. I don't know why it's so slow. I'm just waiting for it to open up. It's still going. Okay. Okay. Okay, so now I'm going to share my screen, and so we'll have some white space so we can work in without erasing the other. Okay, so let's talk about adding and subtracting vectors. If I've got a vector right here, let's call this my A vector. And I've got another vector right here. Let's call that my B vector. That little mark that you see above the A and the B, that's just a mark that reminds me that it's a vector. So if I want to take the A vector plus the B vector, what I do is I take the A vector and I bring it down here. So I just draw the A vector, and wherever the A vector ends, that's where I start drawing my B vector. And so my B vector is this. And so the answer, let's call it the C vector, is the vector that starts where they started and ends where they ended. So this is my C vector right there. So I just drew the A vector, and then wherever it ended, that's where I started drawing my B vector. So does that make sense on how to add vectors?
Yeah.
So, and later we're going to learn how to do it when the vectors go in different directions. So let's suppose that I've got an A vector that looks like this, and I've got a B vector that looks like this. So if I want to do A vector plus B vector, what I'm going to do is I'm going to take the A vector, and then wherever the A vector ends, that's where I'm going to start drawing my B vector. Okay, and so then the answer there, which I'm going to call the C vector, is just the vector that starts where they started and ends where they ended and doesn't care what happened in between. That's my C vector. So that's the way that we're going to add vectors. And I'm going to talk a lot more about this next week after the test. But what about subtracting vectors? What if I want to do the A vector minus my B vector? Okay, I want to do A vector minus B vector. How would I do that? Well, hopefully you agree that that's the same thing as doing the A vector plus the opposite of the B vector. Do you guys agree that that's the same thing? A minus B is the same thing as A plus negative B?
Yeah.
Okay, so if my B vector looks like this, then my negative B vector would look like that. So if I want to do A minus B, what I do is I do A plus negative B. So here's my A vector, and then I'm going to add my negative B vector. So that means it's going to come back here. So then the answer, which I'm going to call the C vector, is just the vector that starts where it started and ends where it ended and doesn't care what happened in between. That is how you subtract vectors. So if you will agree with that, now let's go back to my whiteboard, which I was very careful not to erase. What we want to do is we want to do my V final vector minus my V initial vector. Okay, so That's the same thing as doing v final vector plus negative v initial vector. Hopefully you guys agree. So that's my delta v. Okay, so my v final vector is this guy. So that's, I draw him. And now I need to add negative v initial. So this is my initial vector. So negative v initial is going to be that. So wherever this guy started, I then draw that. So this here is my negative v initial vector. This here is my v final vector. So the answer vector then is the vector that starts where they started, ends where they ended, and doesn't care what happened in between. So what you see in red here, that is delta v. Okay, so note now, why did we go to all this trouble? Well, notice what direction delta v is pointing in. Delta v is pointing to the left. So if acceleration is defined as delta v over delta t, if delta v is pointing to the left, that means that my acceleration vector is pointing to the left. Okay, so I realized this was about 10 minutes worth of what seems like vague, purely theoretical stuff, but it actually will be important very soon. So whenever you're slowing down, if you're moving to the right and slowing down, your acceleration vector is going to be pointing to the left. And this is how you got it. Okay, now, after spending all of that time explaining that.
That makes.
It makes sense? Okay, good.
Yeah.
But let me also tell you that when you take the test next week, I am not going to ask a question that requires you to understand what I just said. However, after the test is over, then we are going to start doing things where you will need to understand it then, but it's not going to be on the test next week. Okay. All right. So Charisma typed in a question to the chat box, and I don't know how long ago she typed it. Are you still there, Charisma? Are you? Let me check the participants list here. Okay, so Charisma is still there. Okay, so she wants to look at question number 12 on the practice test. Okay, so let's look at that. Let's see. Where did it go? Okay, right here it is. I'm gonna have to go back into here again. Sorry, my computer's running so slow. Okay, let's go to the one that has the answers on it. Okay, here we go. Let's go to number 12. Okay. Okay, so Charisma, we talked about this one a few minutes ago, but you weren't here, so that's okay. Don't worry, we're going to talk about it again. All right, so there's one thing that you guys need to understand. When I wrote this test, the practice test, I wrote it a couple years ago, back before coronavirus was here. And my policy back then was that all of my tests came in two parts. The first part of the test, you were not allowed to use a calculator. Or you weren't allowed to use a cheat sheet either. But the thing that's relevant here is you weren't allowed to use a calculator. So what I told all of my students was that when you're working on part one of the test, if you ever need to know what the acceleration due to gravity is, instead of, let me turn on annotation here. Okay. Instead of saying that the acceleration is negative 9.8, just call it negative 10. That's what I told all of my students back then. So there's only one sig fig in that number. Okay, so that is the answer to your question, Charisma. Your calculator tells you that it's 39.2. You are tempted to round it off to 39, which would be the right thing to do if you were using 9.8 as your acceleration. That would be the right thing to do. But because I told the students that they could just call it 10, that means they're only allowed 1 sig fig. So that means they have to write it as 40, not as number 39. Okay, so hopefully that answers your question there. Okay, good. I see that it does. All right. How about other people? All these questions you're asking are really important questions. I wish everybody in the whole class could be here to listen to it. Any other questions?
Is the test we're taking this year going to be broken into 2 parts where we don't use a calculator? Or I don't remember if you said earlier if it was different this year.
It is going to be different this year. I am not going to do a no calculator part because there's no way I could enforce it, right? It would be too easy for people to have a calculator, but it's hidden away. So let me do this. Yeah, so you've got a calculator, but it's hidden away over here and I can't see it, right? So it would be unenforceable. So, so when you guys take the test next week, you are allowed to use a calculator on the entire test. You are allowed to use a cheat sheet on the entire test. And in fact, you can use all of your notes and you can even use the book if you want, okay? But the drawback is that if you need to take the time to flip through the book to find how to do something, you're going to run out of time because the test was designed so it could be done in 80 minutes, but only by somebody who doesn't need to flip through the book. Okay. Now, there will be 2 unofficial parts to the test. The first part of the test is going to consist of questions that are relatively easy, and they're going to be like multiple choice or fill in the blank or something like that. And they're only going to be worth 2 points each. And then the rest of the questions on the test, those are going to be worth 5 points each. Those are going to be more difficult problems. And so those are the ones where I highly recommend you do your work on a piece of paper after the test is over and after you've submitted it and the time limit has expired. Take a photograph of the work that you did and email it to me. And that way, if the answer that you wrote down into Canvas was wrong, I can look to see maybe it was just a silly algebra mistake, and then I can give you partial credit. But I can only do that if you email me your work. Okay? And the answer on your worksheet has to match the answer that you typed into Canvas. If those 2 numbers don't match, then I'm not going to give you partial credit. Other questions?
So when you're doing your work on that one sheet of paper, how far decimals do you want us to go into? So if we have but we do the sig figs and then we get that wrong, for example, like how far is that last example?
Okay, good. Let me give you an example here. I'm going to share the whiteboard here. Okay. So let's suppose that you have something where you have to multiply 2 numbers. So you got 2.1537 times 4.1. Okay. And so on the paper that you do, I want you to show all of that. And I want you to show me what your calculator gives as an answer. So 2.1537 times 4.1. Okay, so I want you to write down the number that your calculator gives you. So 8.83017. I want you to write that on the paper. Okay, and then let's say, well, okay, so we need to decide what our final answer is going to be. So hopefully you guys realize that this is not our final answer. So I see 2 sig figs there and I see 5 sig figs there. So that means our final answer has to have 2 sig figs. So let's suppose that I mess up for whatever reason and I round the wrong way. So I write down 8.9, which hopefully you guys realize is the wrong answer. Okay, but it happens, right? So this is the answer that I write down. Okay, and I type it into Canvas, and then Canvas is of course going to mark it wrong because it is wrong. But when you send me the paper, what I can do is I can see that you did the first part right. I can see that you got the right answer up to here, and I can see, oh, that was what she did. She just did a simple rounding error. So in that case, if this problem was worth 5 points, I could give you 4 out of the 5 points because I can see that you did all this right. You just messed up at the very, very end. Okay. So yeah, show everything.
Okay,
Show
thank you.
all of these. Okay. Other questions? Okay, now I don't hear people asking questions about the practice test. I'm going to assume that's because you understand how I got the answers on the practice test. And I tried to show all the work. So if you don't ask questions about the practice test, I'm not going to go over any of them.
What if it's, hang on, what if it's a question that is a derivative of the mother of all equations, but it's
Okay.
also one of those those pink equations that we have to solve a variable for that.
Okay. Are you afraid that I might ask you to derive it? Is that the thing?
Yeah, derive one of the equations that is derived from the mother of all motion equations.
Okay. Yeah, that would be a good one. If I was really mean, that's what I would do. So what do you guys think? Should I be mean or should I be nice?
Nice.
Nice.
Okay, all right. In that
Be
case, I'll
nice
be
and
nice.
be
Okay.
nice, and you'll make it to the afterlife.
Okay, well, I certainly
There
want to do
is
that.
one.
Okay, I certainly want that. Okay, so here's what I'll do. If I asked you to derive an equation on the test, it would only be the mother of all motion equation that I would ask you to derive. I will not ask you to derive one of the other pink ones.
Okay, so that means that it's only going to be the 3 pink ones we have to worry about in terms when we have to derive from the mother of all motion equations.
No, it's the opposite of that. You do not have to worry about deriving the pink equations.
I know, but I mean, we just need to know them so we know to plug in
yes.
each things. Okay,
Yes.
just making sure.
Yeah, that is correct. So you do know how to use, you need to know how to use them, but you don't need to know how to derive them. Okay, yeah, that's correct. And by the way, I hopefully you guys realize I don't expect you to memorize them. You know, I would expect that you've got them printed out on a piece of paper right there. I don't want you to memorize them. Well, let me rephrase that. I mean, I have no objections to you memorizing them. I just won't require you to memorize them.
All right.
Could you go over some quick, like easier acceleration problems? I don't know, you can make them up or just find them, I don't know.
I can certainly make them up. Do you have one in mind that you would like to make up?
Not necessarily, no.
Okay. All right. How about this? Let's say that we have an airplane. Oh, that's a terrible, terrible airplane. Okay, so let's try that again. Oh, that's not much better, but anyway. Okay, so here's the airplane and it's sitting on the runway at rest. And so then, so it starts moving, and then at some point later, so here's the airplane later, let's say that 17.5 seconds later, the airplane is now moving at a velocity of 126 meters per second. So what is the acceleration? Is that the kind of thing you were looking for?
Yep.
Okay, so I'll give you guys a minute or two. Let's see how you would do that.
I have to go. Will the rest of the will the whole like session be on Canvas?
Do you guys want it to be on Canvas?
Yeah.
Yes, please.
All right. So I can do that because I am recording everything we're doing here. So yeah, I'll put it on Canvas.
All right. Thank you.
All right. So long. Anybody got an answer yet? So when you get an answer, you can type it into the chat box, or you can actually that'd be better. Don't say it verbally because other people are still working on it. So send me a private message in the chat box when you think you've got an answer. All right, I see one answer. I'd like to see a few more. Okay, I see two answers. And numerically, the two answers that I'm seeing are the same, but the number of sig figs is different. So that's interesting. So whoever was the first one to send me the answer, I'm not gonna say any names because I don't want to embarrass anybody. Whoever was the first one to send me the answer, rethink your sig figs. And whoever was the second one to send me the answer, you've got the right number of sig figs. Now, I haven't done the numbers myself, but I'm guessing that you probably must have done it right because you both got virtually the same number. Okay, all right, good. All right, so I'm only seeing two answers there. We got 10 participants. So what about the other 8 of you? Or 7, because I'm one of the participants. Okay. So Lila, would you be willing to tell us how you got it?
Yeah. So, okay, so I just did, so I know that acceleration is the change in v over change in t.
Okay, which is also the same thing as v final minus, hang on a sec, let me do them. Okay, so minus v initial over t final minus t initial. Okay, and then what did you do next?
So I know that t initial is 0, right? Because
Right.
that's your starting. And
Mhm.
then t final was the 17.5 seconds.
Okay,
And then v final I assumed was 26 meters per second.
126.
Oh yeah, 126.
Okay,
And then v initial is 0, right?
okay, very good. You got it.
Why
Okay.
is v initial 0? Like I understand that it's 0, but I'm not exactly sure why.
Well, the only reason it's 0 is because whoever made up the problem said that the airplane started from rest. So if you hear them use the words from rest, that's their way of telling you that the initial velocity is 0. It's like when if I drop a rock as opposed to throwing a rock, if you hear me use the word drop, that means v initial equals 0. Just like if I say from rest, that means v initial equals 0. Okay, is that good there, Lila?
Yeah.
Okay, do you want to do another one?
I think I'm understanding it. I was just worried that I was doing something wrong.
Okay. All right. How about the rest of you? There's 10 participants here. Most of you have been sitting there silently. So I'm a little bit worried there. So Atlas, you were the first one who ever logged on here, and I haven't heard one single word out of you. Are you alive? Same thing with Mia. I say
I'm here.
Jennifer, I heard a little bit out of you. So Atlas, are you alive?
Yeah, I'm here.
Okay, do you have any questions?
Yeah, I was just wondering on scientific notation. I don't understand that, but I just figured, I could wait.
Well, let's talk about it now because I think there's a very good chance that you might see some questions on next week's test about scientific notation. All right, so let's do this. Let's say that I've got a number 57.93 times 10 to the fifth. So I'm going to ask you a question. Is that number in scientific notation? And I want everybody to type into the chat box either yes or no. Is that number written in scientific notation? Ah, very interesting. Okay, it looks like everybody seems to be agreeing that it is not. So Mia, why do you say that it is not scientific notation? Because it sure looks like scientific notation.
Because the first term, like the constant, it's not a number between 1 and 9.
Very good. Okay, so if I were to ask you on the test to convert this number into scientific notation, right? What we'd need to do is first off recognize, because some of you are going to look at it and say, well, it looks to me like it's in scientific notation, but Mia is saying that it's not. She's saying that if we wanted to put it in scientific notation, it would have to be 5 and then the decimal. In order to be scientific notation, it has to be 1 digit and then the decimal, and then the rest of the digits that are significant. Okay, and then times 10 to the something. Now, what should that something be? Because I want the blue number and the red number to be equal to each other. So what would that decimal have to be? Okay, so Caleb is suggesting that it needs to be a 6. Okay, and let's see if that makes sense. The red number right here is smaller than the blue number right here. So when I went from blue to red, I made the number smaller. So if I want the two of them to equal the same, that means that when I go from my exponent here to my exponent here, I need to make it bigger in order to compensate for the fact that when I went over here, I made it smaller. So I agree, 10 to the 6th is definitely bigger than 10 to the 5th. So I agree with you, Caleb. Okay, so this number on the bottom and this number on the top, they are equal to each other, but only one of them is written in scientific notation, and it's the bottom one. So Atlas, does that help clear things up?
Yeah, I was also wondering, how do you turn like a really big number to scientific notation?
Okay, all right. So let's take a really big number. Let's take the number 9,437,052, and let's convert that into scientific notation. So I know that I need to write it as 9, and then I need to put the decimal right there. And then the rest of the digits follow. So 437052. Okay, but now I got a problem because the number on the bottom is a whole lot smaller than the number that I started with. So that means I'm going to have to do times 10 to something. Well, the way I like to do it is I like to look at my original number and I ask, where is the decimal? And I say, well, the decimal's right here. So then I have to say, how many times would I have to shift that decimal to get it to be over here where I want it to be? So I'm looking at it and I see 1, 2, 3, 4, 5, 6. So that tells me that this number right here, the 10 to the, needs to be a 6. Does that answer your question, Atlas?
Yeah.
Okay.
Wouldn't it be -6?
Well, let's think about it. So this number right here was a really big number. So when I put it down here, what I'm left with is a number that's a heck of a lot smaller than what I started with. So if I want these two numbers to equal each other, I better take this really small number and multiply it by something big, because otherwise it's not going to work. So 10 to the negative, oops, that's not a 10, that's, sorry. So 10 to the -6 is a very small number. So that's not going to do the job for me. I need to take my number over here, which is smaller, and I need to multiply by something that's big. So no, 10 to the negative 6 is not going to do it. It's going to have to be a 10 to the positive 6.
Okay, thank you.
Yeah. Any other questions? All these are very important questions. I'm really glad you guys participated and asked these questions. Not hearing any more questions. How about college? Okay, go ahead.
Will there be an equation where where we need to find acceleration with something like velocity and time only?
There might
Or
be.
are there, yeah, like, hang on 1 second. Can you hear me now?
Yeah, I could hear you before too.
Okay, just making sure. So are there any questions where we just need to find velocity or acceleration or time with just one of the other two? Or will we normally also have displacement or distance included?
Well, the best way I can think of to answer that question is to say you will need to use all of the equations that are in that Dr. Seuss handout that I gave you. I'm not going to tell you right now which ones you will need and which ones you won't need, but yeah, be prepared to use any of those equations.
Okay.
If you have a question that gives you every variable you need to know, so like from like x final to acceleration to time, all of them, would you in theory be able to use any of those questions as long as it has the one you're solving for?
Yes.
Technically.
Yeah, that actually happens a lot. Sometimes when I give a test question, some people will solve it using the mother of all motion equations, and other people are going to solve it using one of the other equations. And as long as they don't make any silly algebra mistakes along the way, they will get the same answer. Yeah, that does happen a lot, actually. That's one of the beauties of physics, is that there are multiple ways to do it. And as long as you don't make any silly algebra mistakes along the way, you will get the same answer regardless of which way you did it. So Khalid, you haven't been asking very many questions, if any.
So earlier this week, I was like really struggling with physics and stuff like that. I was really scared about the midterm, but it took some time, and I kind of worked on my own. I printed out the Dr. Seuss equation of motions, and so I think I know it a lot better now. I just kind of came to just, like spectate, I guess, just kind of see.
Okay. All right, that's good. All right. Anybody else got questions?
Could you do the similar thing to what we did earlier, where we do one of the more complicated questions, wait a minute, and then come back?
Yeah, that's a great idea. Let me make up a question just off the top of my head here. This is kind of a question that I like a lot, and you might see it either on one of my tests or later on another test. Let's say that the car is driving down the road, and the car is moving at 26 meters per second. And we want, let's say that the car comes to a stop. And if we measure the distance that it took to stop, let's say that it stopped in 61 meters. Okay. So that means from the time when the driver first hit the brake until the time that the car came to a stop, it moved a distance of 61 meters. So I want to know, what is the rate of acceleration? Now, some of you are going to say, well, it didn't accelerate, it decelerated, to which I reply, you can still call it acceleration. It'll just be negative acceleration. Okay. So I think that I have given you enough information. You might not agree with me, but I think I have. I think I've given you enough information. So your first job is to figure out which equation is going to help you, and then use that equation. So I'll give you a few minutes to think about it. So which one of the equations is going to help you?
Would 26 meters per second fall under velocity initial, V initial?
What do the rest of you think?
I would say yes.
Don't say it with a question mark in your voice. Say it with an exclamation mark in your voice. Yes, because that's how fast the car was moving when he decided to hit the brakes. So that is the starting velocity. That's the initial velocity. What is the final velocity going to be?
0, because
Okay.
they would be at a stop.
Okay, very good. All right. All right, so we know V initial, we know V final. We're looking for acceleration, so I like to put a box around the things we're looking for. How about X initial and X final? What are we going to put for those guys?
Isn't that 61 meters?
Which one? Which of them is 61?
X final.
So it sounds to me like you want to put the origin at the place where the car was when he first hit the brakes, which is, that's a logical place to put it. Okay, so you're going to define that the origin is at the place where he hit the brakes, and so X final then is going to be 61. Okay, so we know X initial, we know X final, we know V initial, we know V final. We're looking for A, but rats, we don't know what T is. Doggone. If only there was an equation that had an A in it and didn't have a T in it. If only. Anybody see an equation that's got an A in it that doesn't have a T in it?
You could use the third one down.
Yeah,
The velocity final squared.
Okay, VF squared.
Because it
equals-
has the 2A in it, but doesn't have the T.
Very good. That's supposed to be an X, not a T. Okay, that is the only one that's going to work for us. Boy, I just cannot write. Let's try this one more time. Okay, yes, that equation right there, that is the only one that's going to work for us, because all the rest of them have T's in them. Okay, so now, from this point on, it's no longer a physics problem. Now it's just a math problem, and you're good at math, right? All right, so I'm seeing one answer. Somebody sent me an answer privately. Somebody else sent me an answer privately, and the two answers are the same. That's reassuring. Okay, so Jennifer, you were the first one to send it to me. So can you walk us through how you did it? So let me make some room here. Oops, I probably should not have erased those numbers, should I? We're going to need those numbers, rats. Okay, so let's see, V initial, we said was 26, I think, right? And delta X, we know, okay. All right, so Jennifer, walk us through. How did you do it?
Okay, so I plugged in all the numbers.
Oh, Jennifer.
Wait. Sorry, I was ahead of myself. I looked at my notes when I was ahead. So I looked at the number or all of our variables that we have, and we have a couple of zeros. So in our problem, we don't need to we can just
Okay. All right, good. So Jennifer is remembering my advice where I said, when we do the algebra, we want to do the algebra using the letters, not the numbers, except there is one exception. If some of the numbers are 0, then it's okay to put them in. All right. So this delta x that we got right here, that's really the same thing as x final minus x initial. Oops. Try that again. Okay. Minus x initial. So it looks like Jennifer is saying, let's go ahead and put in 0 there. And also let's put in 0 for v final while we're at it. Okay, so what we're going to get now is 0 equals v initial squared plus 2a times x final. All right, Jennifer, what do you do next?
Okay, then I subtracted the v initial squared.
Okay, she's going to subtract a v initial squared from each side. Okay, so that's going to leave us with negative v initial squared equals 2a times x final. Okay, what are you going to do next?
Then I divided the 2 and the x final.
Okay, and the 2 and the x final, and whatever we do the right side, we have to do the same thing left side. Okay, all right, so now we know x final. Oops, wait a minute, not x final, sorry. I do that a lot here. Let's try that. Okay, so it's the 2 and the x final that we get rid of. So now we're left with the acceleration equals that. Okay, and when we plugged it in, what number did you get?
I got negative 5.5 meters per second squared.
Okay. Okay, all right, I'm thinking that's good. All right.
Would the negative apply, is that outside the squared or inside the squared?
It is outside the squared.
Okay.
Yes. All right, so our answer will be a negative 5.5. Okay, good. All right, I don't know about you guys, but I'm feeling a lot better. I'm thinking that you guys might actually get some good scores on this test next week. We could do one more, or it's close enough to 4 o'clock. We could just call it a day here. Anybody have a question you're burning to ask?
Yeah, I actually was able to solve it slightly differently with the one. I think it was the x of the x final equals x initial plus half of velocity plus, yeah, that. I was able to first use that one to figure out time because I didn't have a time for it, so I had set it for x, and then I was able to find where it was, or at least sort of. Trying to remember what I put it, but remember that at one point I got, I think it was, what was it? I got 4.692 out of that. Then I made by acceleration x, plugged that in, and then wait, hang on. I then also took the, I think it was the top pink one, and then plugged in velocity final minus velocity initial and multiplied that by acceleration multiplied by time, and I was able to find that it was 5.541 or negative 5.541 in acceleration.
Okay, Caleb, I am super glad to hear you do that, because that proves that I wasn't lying a few minutes ago when I told you that there are lots of different ways that you can solve these equations. And as long as you don't make any mistakes along the way, you'll get the right answer. So did you see what Caleb did? Caleb decided to use a different equation in order to figure out what t was.
I actually used 2 equations.
Okay, good. So, regardless. So he used a different method to figure out what t was. And once he knew what t was, then he started plugging it into yet another equation to figure out what a was. So good for you, Caleb. That's great. Now,
Yeah,
the way
so that way, that means that if you have like only 2 or 3 variables you can use, but they're conveniently able to be put into one equation, you can then take the variable you were looking for that's in that equation and put it in another one as sort of a detour. Like how whenever they're working on roads, they'll always have another way that you could go around it.
Yep. Okay, so Caleb is 100% correct in everything that he did. Okay, now the way that Caleb did it took a little bit longer than the way that we did it, but there's no harm in that. Okay, he got the same answer in the end that we got. Okay, so good for you, Caleb. I'm glad that you proved that there is more than one way to solve this problem, and you do get the same answer when you do it, as long as you don't make any silly mistakes along the way.
Thank you.
Okay, go ahead.
Will you be doing this next week?
What do you mean doing this?
The tutoring session.
If enough people ask me to, I will.
Okay, because it's really, really, really helpful.
Okay, good. Okay. Well, in that case, I just might do that. But I need more than one person to ask me. So talk to your friends. And if we get enough people asking, then yes, I will do it.
Okay, thank you.
Okay. All right, well, this is probably a good place to stop. So unless anybody has any strong objections, I'm going to end the meeting. Do anybody have any strong objections?
One quick question.
Okay.
So if I have, say, 1500 and I report that answer with 3 sig figs, how would I do that using scientific notation? Would it be 1.50 times 10 to the third?
Okay, so 1500 was what you said?
Yeah.
Yeah, so 1.50 times 10 to the third, yes, that is exactly the way that you would do it. So by putting that 0 there, notice that 0 comes after the decimal, right? So if you put that 0 there, well, you didn't need to for a placeholder. So anybody who sees that, they know that you must have had a reason for putting it there. So they know it's significant. So yes, that is exactly the right way to do it. Okay, last chance for questions. Going once, going twice, sold. Okay, guys, good luck on the test. I wish you the best. My pleasure.
All right, bye.
Yeah, thank you, Mr. Hendricks.